Welcome to the Matty Goff Show. I am not Matty Goff. Actually, this is not the Matty Goff Show. I just failed to put up the right video. No, this is CodingKoans, what you're watching. So it's not the Matty Goff Show. It's not made up music. And it isn't any of the other shows that are on Outpost 13, although I love them all, and I bet you will too. My name is Carroll. I'm a software developer, and this is a show where together we're going to explore the world of software, get better jobs, and change the world. As is per usual on my show, I have a guest. My guest today is Naomi Dennis. She is a full stack polyglot software developer, and she works at Eighth Light Software Consultancy. She's a consultant for them. She's here to explore some software with me. Naomi, go ahead and turn on your video, and welcome to the show.
Hi, Ian. Thanks for having me.
Hey, it's good to have you.
It's good to be here.
Yeah, cool. Let me ask you a few questions, Naomi. First of all, where are you calling from, or where are you coming from?
Technically two places.
Oh,
Technically
really?
New York, but actually Georgia.
Okay, so I take it like you're attached to the New York office, but you're actually in Georgia right now.
Yeah, I'm on what I'm calling a COVID vacation at this point, where I'm actually visiting my parents currently. And I'm kind of just enjoying the warm weather, or rather the not snow that's happening.
Warmer weather, yeah.
Yes.
Well, cool. Thank you for being on the show. Speaking of which, since we're talking about COVID and we're talking about the nature of software development work right now, you've been working remote for the better part of a year.
That's true.
So let me ask you a few questions about what it's like to do remote software work versus doing in-person or co-located software work. What are the pros and cons of that? What's been your experience with that?
I would say it's been kind of tepid. Sometimes I like it, sometimes I kind of hate it. I do very much miss the folks at the office. And oddly enough, commuting is a big thing that I miss because it kind of separates your work life from your home life. In New York, the subway system is a big part of the city. And so I kind of miss, the dings and the smells and the grime.
Uh,
Yeah. But I would say in terms of like actually working, it's the benefits of it is that, you save a lot of time in the morning. Uh, in my opinion, sometimes people can be a bit more focused because it's like you're kind of just there as opposed to being in the office where sometimes that can happen. But I guess for the office I was in, everyone was very close together. So you kind of heard other conversations as you were talking with other people. And that could be distracting. The other thing is, I kind of just really am liking the landscape of Georgia personally. It's very open fields, lots of trees, and there are a lot of deer near where my parents' house is. Surprisingly, I've
did
seen
your
about four so far.
did your parents move to Georgia or did you grow up there?
I partially grew up in Georgia. I came here when I was 8, and then I returned to New York for college, actually. And I kind of just stayed there because I just fell in love with the city and all the things that it has and the vibrance and the life of it. It's nice. It's been nice having a little break from it, but I definitely do miss the Big Apple.
Hmm. Yeah, I hear you. I personally, New York is not my city. It just never has been. I'm definitely more of a West Coast kind of person as far as my
Yeah,
temperament is concerned. But um, I can appreciate how others appreciate it. There's
that's a good way of
and
saying.
yeah, it's it's nice to just be amongst other people.
Yeah,
Hmm.
that's definitely the biggest drawback,
Yeah.
especially with pairing, which is like very big thing at Ace Light. I very much miss just walking up to someone and being like, "Hey, I noticed that, we talked in the break room and you're working on this Elixir project, and I can help with that if you'd like." And then you just start pairing on it.
Right. Okay.
Yeah. So
So
it's
pairing is in pair programming, and where two people sit down at one computer, which is kind of what we're going to do here in a little bit. Um, so it's not quite as impromptu as that, but it will be something that you're not expecting because you don't know exactly what we're going to tackle. Actually, I don't either. So that's kind of exciting. Before we get into that, though, let me ask you, how did you get into software? So let me start with it.
Sure. So it's kind of like software was sort of the last stop on a long road for me, namely because my dad actually got me into computers because he used to work in it a little bit when he was in the military. And then once he left, he did it a lot as a hobby. So he would just like fix up computers. And then at one point, he just started making just giant computer towers, like just of all the random parts that he found. Eventually, I watched him do it because one of my computers broke, and so he fixed it, and I thought it was amazing because he just like changed, I think, like the RAM or something, and it just worked. And so then he just started showing me like, this is a RAM, this is a motherboard, this is a CPU. And so by the time I got to high school, well, middle school, I started taking classes in like, just overall computer stuff, I guess at the time. And I actually initially wanted to be a tech support person when I was younger because I really liked fixing up computers like my dad did. But when I was in high school, I discovered programming because a teacher saw that I really liked fixing up computers and he was like, hey, why don't you try learning this thing called Java? Because he also heard that I liked video games and he was like, you can make games with it. And so
Ah, nice.
yeah, so at that point it was history. And then one day he just kind of told me when he saw that I was taking it seriously, like, hey, this is a job, right? Like once you finish high school. And then that was pretty much it. And from then on, I was like, I want to be a programmer. It's going to be so cool when I eventually can do it. And yeah, and then I went to college for it. I worked for a lot of startups before A-Flight, which were all very interesting in their own way.
Oh yeah, I bet.
Yeah, and then I eventually came to A-Flight because someone recommended it to me because I kind of felt stagnated a bit, because startups are great for sort of just getting your diving into the world of programming, but
Yeah, you got to produce
it's
something quickly.
exactly.
Yeah.
And so, A-Flight with its virtue of like, quality and solid principles and things like that just really appealed to me. So it's been great. And that's sort of how I got here.
Cool. You went through the apprenticeship program too, right?
I did. The apprenticeship program was actually really, really interesting. I had to sort of unlearn a lot of bad habits uh, that I kind of grew into over the years.
Mm-hmm.
And the thing, and I would say, if I had to summarize the apprenticeship, was that if anyone is ever familiar with the cave story of like the people in the cave with the shadows on the wall and they think the shadows are the entire world, and then one day they get out of the cave and they realize that no, those are just shadows, it's not the entire world. That's kind of how I felt about code. Like I knew you learn code to do stuff. This is a database, this is a website, this is a mailing thing, whatever. And then Nate was like, hey, did you know that is also that? But if you use this architecture pattern, you could actually do all these wonderful things with it. And if you actually follow TDD, you won't backtrack as much and you won't have to deal with as many bugs in the future and so on and so forth. And so it's just been like just a mind blown gift just over and over again.
Yeah.
In terms of
Yeah, that's Plato's allegory of the cave. Nice philosophical reference there. Um, so you said TDD. Maybe not everybody knows what those letters mean.
yes. So TDD stands for test driven development. And so effectively what it means is that as you're developing code, you're actively testing it at the same time. So there are two different approaches you can take to this. I believe like the company I work for, well, you and I work for, they typically want you to say like, I want to write code that does this. I expect when I run, say, a function that it will give me this number. But then there
So
are
a function that
others.
is adding 2 plus 2. You're going to expect that
Yes,
you add 2 plus 2 and that the answer you get back is going to be 4, right?
exactly.
Yeah.
And so you can do it that way. Sort of think of it like you're, I don't know, making a wooden box. And so you're sort of testing to see like if it's holding correctly. And then you have the other school of thought, which is doing the testing after the code is written. So say
Okay.
you write an addition function, as in you just tell the computer, here are two numbers, give me this two back,
Right.
the sum of them. And then afterwards, you write a test saying, hey, will this happen? What if I give it two different numbers? What if I give it two things that aren't numbers? What will it do? And so that's sort of what TDD is. It's a very useful coding philosophy, I would say. Very much worth looking into.
Yeah. In fact, we're gonna play with that pretty much right now if you're ready for it.
Oh, let's do it.
Okay, cool. So first I need to share my screen with you. Let me just do that. Let's go with this one. So now you should be seeing nothing, right? Just a bunch of ones and zeros.
That sounds about right.
Okay, cool. I'm just adjusting some things on my desktop because that's how this show happens. It's just my desktop being streamed and that's it. All right, so here we've got a set of exorcism challenges in different languages: C++, Elixir, Go, JavaScript, Ruby, Rust. We've done a bunch of these on the channel already, but we decided we're going to do Python. And each of these have a little koan, or a little problem for us to solve, and then perhaps figure something out or learn something about software when we do it. A number of these, let's see here. The reverse string, a previous guest was working on that one with me. And so we created a, is it a palindrome function based off of the reversing string function. So that might be an interesting one to look at and maybe refactor. Or we could try something that has been neglected for a long time, like the RNA transcription, or this leap year function, which is going to, you give it a year, it tells you whether or not it's a leap year. And then this new one that we just got in is word count, which is just going to count the number of words that are in a text document, or just a bunch of text, really. It's just going to be, it's going to be a string. And it's just going to see how many words are in that string, and it's going to give you back not just simply the number of words that are in the string, but a breakdown of each type of word that is in that string. So we could do any of those, if any of that sounds interesting. We also have like this pangram thing or anything else here. Anything look interesting to you?
Ooh, I'm trying to decide between the leap and the word count, because the leap year one sounds quite interesting. I think we should start with the word count, since that's fresh, hot off the presses.
Probably going to be the only thing we do today. Are you ready for that?
Yeah, I think I'm ready.
All right, here we go. Let me just sort of move this screen around just a little bit so that we still can see ourselves on here. Okay. Peyton Rules is in the chat. Hey, Peyton Rules. That is Eric Smith, and he was on the show a fortnight ago. Welcome back. So it looks like we've got a README, we've got a word count test, and then a word count that's been brought to us just automatically. And along with that, let me just bring up this terminal. I think we're inside. Yeah, let's go into word count. All right. I think if I just do PyTest, we should just get a bunch of fails, which we do. Okay, so there's a bunch of tests that are pre-written in this. They're going to be in our test file. We also have this README, and we have this word count. Where do you want to start?
Let's start with well, I think you explained it well enough. But just in case, let's start with the README.
Okay. Nice. We're going to start by reading what's there. All right. So because word count could mean a number of different things. We could interpret that in a number of different ways. A README like this can help us figure out exactly what precisely we need, right?
That's true.
Yeah. Okay, so given a phrase, count the occurrences of each word in that phrase. For the purposes of this exercise, you can expect that a word will always be one of the following things. Either it's a number composed of one or more ASCII digits, a simple word composed of one or more ASCII letters, a or they, or a contraction of two simple words joined by a single apostrophe. Looks like we're not dealing with hyphens right now.
That's good.
When counting words, you can assume the following rules. The count is case insensitive. So you and you and you are three of the uses of the same word. The count is unordered. The test will ignore how words and counts are ordered. Other than the apostrophe in a contraction, all forms of punctuation are ignored. And the words can be separated by any form of white space, like a tab, a new line, or a space. So we're starting to get this. The Exorcism Challenge has done the hard work of figuring out exactly what it is that we're trying to do, which is going to help us out tremendously. A lot of times, half of our work as developers is trying to figure out what it is we actually need to do. So it looks like, okay, so do you know what an ASCII thing is?
Ooh.
What's ASCII?
I don't remember what it means, but effectively it's the table that kind of has what the computer interprets letters and numbers as.
Yeah, okay, let's look that up.
Ooh, nice theme.
Oh yeah, it's a default one on Opera. We went to Google, and we're going to ask it ASCII. There's a Wikipedia article right here. Okay, yes, I know. Please donate. Speaking of which, you can also donate to this channel as well by subscribing, by cheering bits, or just by watching. Thank you for being here. That helps out this channel and all the content that we provide here, not just CodingKoans, which is a software thing, but we also have ones for music. We have different improv shows that happen here. We have geek-friendly shows. There's one where where they just chat about different fictional characters that they're in love with, literally. And then there's also a show that's just about whiskey, and they just drink whiskey on the show and talk about whiskey. It's called I Effing Love Whiskey. So yeah, all kinds of stuff here. But let's look at ASCII. So American Standard Code for Information Interchange. Wow. So it looks like it's a code that turns numbers into letters. And it's basically arbitrary, but it's an arbitrary way of encoding characters so that everyone is doing it the same way. So it includes all the things that you'd see on an American keyboard. Pretty much that. And then a few, control characters, such as, the new line or the tab, which are different types of white space. Also the space. That's an ASCII character as well.
That's interesting. I would have never guessed that.
Yeah. And each one of these ASCII characters is a set of bits, it looks like. Here's a table. So that's a space. It's just 0. And then, yeah. Okay, well.
Ah, I see. That makes sense. I think I've only ever seen ASCII in terms of like hex or like a just regular number like 13 or something. So that was very interesting.
Yeah.
Never seen a binary reference for it before.
I mean, yeah, it's not. And notice that ASCII characters don't include things like Japanese kanji, or like the special quotation mark that has the little swishy thing at the bottom, or any number of other like symbols or emoji are not included in ASCII as well. That's encoded using something called Unicode, which is a different encoding scheme that encompasses more things. But yeah, for our needs, we're going to be building strings of ASCII characters. And here's an example of a string right here. It's just quotation marks around a word. And that's how the computer knows what a string is. It's just a string of characters. Each one of these is an ASCII character. And then when you put them all in a row, they're called a string. Right? Okay, so enough bits of computer science there. All right, so for example, the phrase, "That's the password, colon, quotation mark, password 123, exclamation point, cried the special agent. So I fled." The count. And so we are expecting that this is what comes out the other end. When we put
So
this
not just a
in,
sum.
we're going to get this out. This is already starting to be like a test right here, right? You can see how you could construct a test around this.
Definitely.
Okay. Exception messages. We might do exceptions. Let's see. Do we deal with them in this time? Meaningful error message to indicate what the source of the error is. Yeah, that helps other developers when you do that. This makes your code more readable. Helps significantly with debugging. I don't think we'll need to raise an exception this time, but I mean, we can consider it. I'm not sure if we want to raise exceptions when we're given something that's not a string, for example. Like, what if we're just given true or false? You know, raising exceptions along those lines would be helpful.
Yeah.
But yeah, looks like we can run the tests, which I already did. Just run PyTest by itself. And as long as, since I ran PyTest to do this, just PyTest, not PyTest word count test.py, this points it at this specific test file. But if you just run PyTest, it'll discover whatever is in the directory that you're in right now. So we're in pwd, print working directory. So we're inside my folder in exercisms and Python and word count. So it's going to look for anything inside of word count and see if there's a test there. If it's a test, it runs the test. And you can also give it verbose output, stop running tests after the first failure, run failures from previous tests before running other test cases.
Fail fast is a favorite indeed.
Yeah. Okay, so that means that if we did PyTest -v, we should get a lot of stuff back. Yeah, gives us a whole ton more, right? Great. And then if we do PyTest -x, it'll just give us that first one, and that's it. And then we don't have to comment out all the tests that are not included. And if we were to do PyTest -ff, we should find the same issue going on. Oh, looks like it doesn't like that. Is it --ff? Yeah, it is.
Yeah.
Okay, well that does exactly the same thing as a regular PyTest does. So I'm just going to use PyTest -x right now. So it looks like we start with a failing example, and this is what we do, right? For test-driven development, we're not afraid of failures. Failures are not bad things.
Yep. Sort of just pointing you in the right direction.
Cool. Okay, so here's our first failure. None does not equal 1, 2, 3. I suppose we could just ignore the tests if you wanted to and look right at the word count.py and start trying to make this test pass, or we could actually look at what's in the tests. What do you want to do?
Ooh, let's look at the tests.
Cool. Here we are. So
There it is.
here's our test count one word. And then, but that's not the one that's failing, because it's failing, it's just going to fail the first one it runs, but it might be failing a different one each time. So maybe I should start with this first one and then uncomment this stuff over time. All right, let's do that. So we're going to comment out all of that code. By making it a comment, it just means that the code won't run. No, I don't care about that. I don't want a linter right now, thank you. This will be fine. I'll just simply be careful. All right, well, we can just run PyTest. Yeah. All right, so here we are. None does not equal word colon 1 inside of an object. And actually, this isn't an object in Python. We call them dictionaries in Python.
So like you'll have a sort of like a term and then the value of that term.
How many of those there are. That's right. So we're going to create a set of key value pairs. The key is going to be the word, and then the value is going to be how many times it was counted. And
Sounds like a plan.
And so, all right. So how do you want to approach this?
So it looks like it takes in, well, first we'll start with what, or I guess like a function, it sounds like.
Okay.
And okay, so there was already a function there.
There's a def count words, and then it takes a sentence as a variable argument. And then it does nothing with it, it just passes.
So what if we split the word by its spaces and count what returns?
Yes, we can do that. Okay, let's try it. So what is it? Sentence. Like that, right?
Yeah. Oh, I think there's a typo. Yeah, by split.
Spit. Spit that sentence. So. Okay, so that turns it into an array, right?
Mm-hmm.
Okay, and now what do we want to do?
So I suppose from here we can convert it to a dictionary. So is there a Python to
I believe that should be it. Has no attribute to dict. Okay, so let's do a little Googling. Let's try and figure out how we do that. Oh, here we are. This is the first thing. Well, this is converting a list to a dictionary, but this is not going to do exactly what we expect it to, right?
Yeah.
Because we're not given what these values are yet.
So I suppose, I guess, an easier way to pass the test is what if we just return a dictionary with the word and set the value of that to 1.
What you mean, like copy what the expectation is?
Yep.
And then just return it.
Yep, exactly like that.
Let's see what that did. Yep, that
Hey.
passes. All right, congratulations. We've got the first one done. Now we're going to get this a little bit more. So let's see here. Do we want to refactor before we move on? Now that we've got this green.
Yeah, that sounds like a good idea.
Peyton Rule says ship. That's it. We're done. So I don't know. Let's call this. Word count, word report. What do you want to name this?
I think word counts is good.
Okay, now we've defined it as a variable. It's still working. Anything else you want to do to this before we continue? We could maybe use sentence somehow.
Yeah. So sentence is just a string, right?
Right. It's just a string.
So is the sentence in this case just one word?
Yeah.
So what if we just return sentence instead of the string?
All right. Now we have moved away from hard coding our answer. And look at that. Okay. So now we've got we've got the basics of something going on here. Is this enough for us before we start moving forward? I don't want to start anticipating what we're going to need next, but
Oh yeah, this looks like more than enough.
cool. So let's go ahead and move on to what our next test is. Challenge 2. Uncomment it and run the tests. There's our failure. So, assertion, one of each does not equal one of each.
I disagree.
So, yeah. All right. So, right now, we're just taking the whole string, sticking it into the dictionary, giving it the value 1, and putting it forward, and that worked as long as we had one word in our string. But now that we've got multiple words, how do we accomplish this one?
Huh. Well, this looks like a good time to possibly introduce looping along with splitting the string.
We
So maybe
could.
doing it last time was a bit premature.
Oh, yeah, yeah. Now, when we split it, though, that does create,
Oh, a list. That's right.
let's do a word list. And we'll call it sentence. And we'll do split. We'll split it by any white space.
Yeah. So that definitely sounds like it will return a word list. So now we just have to, I guess in this case, there's
Get
only
this.
one of each. So yeah, so just return a object where each word is a key with a value of 1.
Now we would say, oh, look, there's some nice things going on here. How do we loop in Python? Let's figure out the different ways that we could loop through this. Why is this? Oh, that's why, because I had left it from the last time. Iterate over a list. Here we are again. Here we are, for I in list, print I. Okay, looks like that's how we do it in the Pythonic sense. So, let's define it this way. Create an empty word count. And then we for word in word list, colon, I believe we need in Python. That is proper Pythonic syntax, yes. And then we're going to do something. And in this case, we're going to say word count dot, and my VS Code is giving me some helpful things that we can add to it. We don't want to pop. Update, no. Copy, clear. Values. Is there an append?
Maybe a set?
What if we define it this way? I think we can do this. Word count, word, equals 1. I think we can do it that way. So what this is doing is we're accessing the key inside of the object. And since there's no key in there, there's no word yet, I believe Python is just going to make it for me when it's not there. And it's going to assign it to the value 1, right?
Yeah, that sounds good.
That seems like a reasonable thing to try. Let's see if I'm right or wrong.
Oh.
That works.
Oh.
Okay, well, looks like you can just do that. So you don't need, this is interesting. It looks like a dictionary in Python. You do not need to actually define the keys before you start assigning them values. As soon as there's a key, it creates the value that goes with it. Or it just creates the key, and probably if you were to do like, you do have to assign it to something. So if I was to do like none, which is a Pythonic type that basically means null or whatever, not undefined. There we go.
Ooh, see if read.
That means that we did it right. Because look, each of one, or one of each, none, 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 instead of 1, 1, 1. Cool, so this is good. So far, so good. Nice.
Awesome.
Any refactoring you want to do before we proceed to the next step? Anything you see that could be maybe done a little bit nicer or different?
I am curious in one thing. Namely, does the for loop return the object it was iterating over? And if it does, can we just return that?
What an interesting thought. I believe the way that Python works is that a for loop is returns nothing. Unless, of course, you give it an early return. In which case, the function that calls the for loop gets returned at that point. It gets returned with that value. So
I see.
So it's unlike some other languages where there's a return value for absolutely everything. Python is a language that allows for side effects. And technically, I suppose this is a kind of a side effect, isn't it?
It looks like it is.
Yeah.
So what about, if you define word count only in the for loop, will it still be defined in the greater scope of the function?
I don't think it will be, but we can find out. Let's try it. I don't think this is going to work because it's going to define,
Oh, I meant if you removed the assignment completely.
Oh, I see. If you just didn't even bother.
Yeah.
Python doesn't like that. It goes, what the heck? I don't understand. What's a word count? Where's that coming from? Looks like you need to define it.
Very interesting.
Okay, well, we learned that about the language. So with Python, how is this reading right now? Like, personally, I like code that reads like it's prose, and it says exactly what it does. Is this saying what needs to be said and leaving what does not need to be said unsaid so far?
Yes.
Okay.
I do think it could definitely be written in more of a prose fashion.
How would we do that? Or do you see any opportunities for that right now?
Um, Somewhat. Like maybe in the for loop, instead of it being word, it could be like for the next word or next word in word list, and then it assigns it to the word count.
Next word in word list. Word count, next word. Like that.
Yeah.
Okay.
And this might be a little premature,
Mm-hmm.
but what if for the word list, instead of explicitly writing sentence dot split, it could be a function that's maybe something like break sentence apart or break into words.
So
Or
instead of calling it word list, which is sort of using the variable name to define its type, you're
hmm,
talking about broken sentence
yeah.
or divided sentence.
Yeah, I think that's more clear.
In our divided sentence, which is a modification of sentence, or for that matter, yeah, okay, let's try this first. Let's not get ahead of ourselves. Yep, that's still fine with that. What if we reassigned sentence with sentence? Can we do that in this language? Can we say, I want sentence to now be this instead? Can we do that? Well, we can. Do you like that better or worse?
For next word in sentence, I like it. It's definitely clear.
Okay. So we're going to, all right. So this is a fun thing about Python. It's going to evaluate what's over here before it figures out where it's going to put it. And so it reads sentence and then operates on it by split, returns that, and then assigns it to the thing that it referenced in the first place.
Hmm.
Yeah, which means that we can write things that look a little bit more like prose. For next word in sentence, word count next word equals 1. Okay, cool.
Yeah.
All right, are you ready to move on, or are you seeing other refactoring opportunities before we do?
I think it's time to move on.
Okay, cool. Let's do that. Alrighty. And comment that.
Ooh, our first non-one number.
Ooh, one
This will
fish,
be
two
interesting.
fish, red fish, blue fish. This will be interesting. Yep. So, this is getting a little hard to read unless I pull it out a little bit, so I'm going to do that. So, one fish, two red, blue does not equal. Oh, that's interesting. Fish is oh, it looks like this is not what I was expecting to have happen. I was expecting the word fish to show up multiple times, but it didn't.
Ah,
Because each time, right, I think you see where I'm going. Why is it
yes.
that, so we get back, let me just use this little space down here as a little tiny whiteboard. So we're getting this back. What I was thinking we were going to get back was this. One fish, two fish, red fish, blue fish, right? That's what I would expect to get back based off of how I was thinking about this code a second ago. But I'm wrong for thinking that because obviously it didn't produce that. So why didn't it? Why is it just say fish one when they're actually, when we referenced fished 4 times?
It could be that the dictionary is seeing if an entry is there of a particular name, and then if it is, it just overwrites it with with the value that it's given.
Okay, so that means that it's referenced fish 4 times, and each time it has assigned it to 1. Good to see you, Peyton Rules. Have fun. Thanks for stopping by. Yeah. So yeah, it's going to check to see if it's there. If it is there, it's going to assign it to 1. If it is not there, it's going to create that entry and assign it to 1. So now we have to sort of separate out when it already exists, right?
Mm-hmm. It looks like we should be able to do this with an if statement.
Okay. So we're going to use a conditional, an if statement, the particular type of conditional we're going to use. And so we're going to say if
Like, so this will be interesting because we have to check if the next word is already counted.
yeah. How do we
But if we,
check to see if that's in the array
yeah,
or in the dictionary? Wait, can we do that? Maybe Python has a way to do that internally.
that that definitely sounds like Python.
It sounds like something that maybe Python would be able to do. So let's check.
Yeah.
So Python check if key exists in dictionary. All right, let's just take a look at this first one here. Has key.
All right.
All right.
Oh, there's also an if in statement.
Dict.hasKey. Key.
Oh, there's also an if in statement.
Yeah. So if fruits has key, key to look up, key exists, key does not exist. Or the if in statement. So if key in dict do this thing. Wow, that definitely seems more readable than key.hasKey blank, right?
I agree.
So maybe we use this one because that's going to read a little bit more friendly to future us or whoever comes in after us here. So if word in word count colon. Yeah, that seems right. Let me just see. Yeah. Code,
Yeah.
else, code. We don't need to bother with an else because I think that Python is one of those languages that if you don't put in an else, it just ignores it.
I do think we want to replace word with next word in the if statement.
Oh, yes. Good call. If the next word is in the word count, what do we do? Word
Let's see.
count.
You probably want to increment it by
Okay.
1.
Incrementing it by 1. Nice. So we're going to reference it, even though it actually, we kind of did do something that's almost referencing it up here, but we're going to, after we check it, we're also going to come back in and we're going to increment it, which means we're just going to add 1 to whatever the number is. I believe in Python, much like in a lot of other languages, you can just do plus equals 1 as a special way of assigning the value to be 1 more than whatever the value was before it.
Oh, wait. There's
Nope.
one.
Next count is not
Or
defined
not defined.
because I said next count instead of next word. Almost.
Yeah. So this is a question. Does Python have a continue keyword?
It may, or it may break right there, or we can use an else. Because it looks like this word count equals 1 is clobbering whatever this is, right?
That's true.
So maybe we do need an else. Is else this? I think you use a colon there. Python likes colons. It's one of the things about Python. You will not see any braces, but you will see colons. Well, I mean, technically these are braces, but that's a dictionary. That worked. That was it. Looks like we need to put it into an if-else block. Okay, well that's passing. This is getting on 9 lines of code. Is this starting to make your eyes cross a little bit the way that this is written?
Ever so slightly, yes.
Okay, cool. So at least we're feeling that we'll probably want to refactor this at some point. I'm not sure if we want to do that now or later. I'm not sure if maybe we can use a ternary or some other kind of conditional instead of the if-else block.
Yeah. I could see using a ternary. My only concern is like, what if there are more conditions
True.
to the if else?
Yeah, there could be. Now, what we could also do is whenever I start seeing things nested like this, I might actually take this and turn this into its own helper function.
I like that.
All right, so let's try that. What's our helper going to be called? What's this thing doing?
Maybe counting duplicates. Possibly?
Counting duplicates. Yeah, but it does more than that. It also, if there's nothing else in there, it's going to assign it, right?
Ah, that's true.
So, I mean, we could make this. I mean, we could abstract this into its own function, next word in word count, and return that. But this is already reading pretty clearly. We could abstract this into its own function to say increment the word, or we could abstract this into it to say create new word, or we could abstract this whole for loop into one. How do we want to handle this abstraction?
So I guess we can decide that so we know what it's doing is it is counting duplicates and creating a new word if no
Right.
duplicate is found.
True. Perhaps it's populating the word count?
That's a very good phrase. Yes.
Okay, let's try that. Populate word count. And it's going to take a word and a word count, right?
Mm-hmm. Maybe we should rename word count.
Oh, yeah. First of all, I'm using the wrong kind of casing. We're trying to use snake
good
case
catch.
in Python. We might.
Maybe it could be words counted.
Could be. Yeah.
Yeah.
Let's we'll consider that in a second. So or what if we take a sentence and a word count? And then we do it that way.
I would change one thing, which would be what if we defined the word count in the populate word count function
Ah,
and
yeah.
then just returned it? Yeah.
Yeah. So we've
Ah, yes. Function signature.
mm-hmm.
Mm-hmm.
That works. So now we still have this nesting thing going on here, and a lot of our stuff is in here, but at least we've sort of pulled out the sentence part into it.
Yeah.
Um,
We can try to flatten the if else
uh-huh. So
by sorry, what?
before we do that, did you want to change the word count to something else?
Oh, yeah. So what if we changed word count to words counted? Because word count kind of sounds like it's a number, which technically it's like a list of well, a dictionary of numbers. Hmm. But what if we flatten the if statement? Oh, there's still a few more places to
Well,
change it.
maybe we
Yeah.
can just change this to words. I know it's technically the same thing, but just
I think in the context of the function, it makes sense.
yeah, it does. Okay, cool. So,
Yeah. So if we were to flatten the if statement there, we could sort of take out the else. And this might be a cool question, but in some languages, you can use a continue keyword, which effectively just says go back to the beginning of, go to the, like, start iterating the loop again on the next count versus continuing all the way through whatever else you have. So that
that's
way,
okay. I can see that using a continue. I had this other idea. I'm not sure if
oh,
Python will allow me to do this, but Python already kind of does this thing, right? It checks to
mhm.
see if the word is there, if the key is there. If it's there, it adds one to it. Otherwise, it doesn't do anything. But the question is, what happens when there's nothing in the key yet? I'm wondering what happens if I just pull out this whole if-else block.
Ah, I see.
I'm wondering whether this will throw some sort of error or whether or not this will still be valid Python.
I'm gonna bet that it would. Oh no, I thought it would still be
Key
valid.
error 1.
Hmm.
Okay, never mind. That would have been really cool if it was that kind of language. And it almost is, but it isn't.
Yeah. Hmm.
Let's just bring us back to passing. Good. Okay. So you had an idea of continue, right?
Yeah.
Let's see how Python deals with continue. Break, continue, and pass. Oh, that's interesting.
Oh, pass was what was there. Uh, it was in the body of the count words at the
Yeah,
beginning.
right, it was. So we can break.
Okay, so break stops the loop.
Yeah, so in fact, if you were to do that, I think it would look like this. If we were to use break, it would be like, um, wait, you don't use semicolons in this language. You would do that.
Yeah.
No, it hates that. um, oh, yeah. Because it needs to be the other way around, I think.
Hmm. Ah, I see.
White space matters in Python, by the way. So, like, this space here being a tab like this is very important in this language. In other languages, that doesn't matter, but in this one, it really does. Now, it still doesn't like that.
Hmm.
I don't have the time to try and dissect why that's broken. I'm just not going to do it. Okay, so we can't just do break right there and expect that to work. So what was the other idea you had is continue, right?
Yeah.
If letter H, continue. The continue space statement in Python returns the control to the beginning of the while loop. Continue statement rejects all the remaining statements in the current iteration of the loop and makes control back to the top of the loop. So, what would that mean?
So it's sort of like if we were to put a continue where the else is, but sort of reverse the indentation, so bring the words. So I guess first, if we were to remove the else and replace it with continue and indent it so it's in the if statement.
Like that, right?
Yeah. And then if we were to bring word count, like the assignment of word count, outside of the loop, but on the same level as the if statement. Outside of the loop, I'm sorry. Outside of
Oh,
the, yeah. So like that.
I see what you're doing.
Yeah.
Like
And
that.
theoretically,
Not outside the loop,
yes, not outside of the loop.
but it will ignore going on to this step. It will come down to here, hit continue, and go back up here to the next word. And so it won't do this.
Exactly.
You're right. That's how it works. Um,
Cool.
it is, we're a little past time now, so I think this is about as far as we're going to be able to get.
Ah.
Yeah, I know, we were on a roll. I'll stop sharing now so that you get a full screen. What did we learn today?
We learned about dictionaries,
Dictionaries, right?
and also about for loops,
Mm-hmm. For loops.
and sort of also about the flow
Yeah,
of a
sort of
program.
a control flow almost, right? Is that how
Yeah,
you'd call that?
control flow sounds right.
Or we need to use a conditional in order to make it work, right?
Yeah.
Yeah.
And I would also say, I guess, how to read tests, because we had to read the test in the, ooh, it's not called a spec file, py test
Yeah.
file.
In the test
Yeah.
file. Yeah.
Yeah.
Test or spec. It depends on the language. Sometimes it's test, sometimes it's spec. Yeah. But yeah, it's not a spec file in this case. It's a test file. If it was
Yeah.
JavaScript or Ruby, it'd be a spec file.
Yeah. So I guess reading the test file and interpreting it, and also
Mm-hmm.
running it, and sort of doing the correct me if I'm wrong. It's been a little bit of a minute, but the
Mm-hmm.
red green refactor method.
Yes, we did that.
Yes.
So we started off with a failing test. We got to the point where it was passing, and then we cleaned it up a bit and made it nice while keeping it green.
Yeah.
Yeah.
And hopefully in the next episode, the importance of good naming,
Oh yeah.
because it'll
Yeah.
be very easy to come back to this snippet.
True, yeah. Naming things well, naming it, reading, having it read like prose, having it be abstracted in a way that makes sense, that makes it easier to read. All very, very nice things to have. Unfortunately, though, this is going to be the last episode for a little while.
Oh no.
Yeah. So we're not going to have a
Oh.
next episode for a bit. This is the end of version 1 of CodingKoans. And Naomi, it's really great having you on as a guest for that.
Thanks.
Yeah.
That was such an exciting season finale.
Oh,
I
yeah.
had the edge of my seat the entire time. It was red, then it was green.
And then we refactored it, and wow. Right. So I have two big questions to ask you, but before I do, I need to thank a bunch of people. Um, so the show is produced on Outpost 13. My production liaison is Matt Pittner. He does numerous things, but one of the shows that he has on the channel is called Crockpot Cinema, where he will cook and also watch a movie. And it's a cooking show and a movie watching show. Then there's Aaron Harvey. He's the designer for us that created this background and some other various things that were very pretty. Aaron has a show called Infinite Trek. It's about Star Trek. That's on Saturdays. Marketer is Lucas Fanasic, who is the game show host of a game show called Two Liars, where you have two teams of three. They're going to make a statement, and one team has to figure out which of the three people on the other team is actually telling the truth. The other two are totally lying right there on the spot. Then Botmaster is Cody Bushy, who has a show called An Actor Unprepared, which is a show where he brings together an actor, a director, and a writer, and they look at a monologue that the writer has written, and they produce it for the first time right there on the stream. So you get to see their process. Music that you heard before the stream, and what you'll hear after the stream is by Made Up Music, and that is the pair of Arlo Sanders and Alex Kahn. They have a show that is called Made Up Music that's here on the channel. You can see that in the background, but basically they'll make up a whole song based off of your suggestions. And you can find their music on both Bandcamp and on Spotify. So if you look on Spotify and you search for Made Up Music, you'll see what they produced this year. And besides those people, I also need to thank my mentors as well. That is the mentors who allowed me to be a software developer. And I wouldn't normally do this on most of them, but since this is the last one, I need to give a major thank you to Justin Dorfman, to Drew Adams, to Machiko Yasuda, and to Dave Moore, all of whom in various capacities, either formally or informally, have been my mentors. And it took at least those four, plus dozens of others, to turn me into a software developer, and each of them took the time out to do that for me, which is part of the reason why I'm doing this show. Naomi, you have anyone you want to thank before we go off to the last questions?
Oh, I would thank you and all the people you just mentioned because I think this is like a really cool like usage of like Twitch
Yeah,
and like actually doing the CodingKoans and everything. I think it's a really really good way to show people like an insight into coding. I think it's great.
cool. Yeah, yeah. Well, thank you. And before we go, two big questions. One, what do you think is the most important thing to remember about software?
Ooh, the most important question. I would say always approach your code as if someone else is going to read it or use it. And that someone else doesn't have to be an actual person, but it can be you from uh, you, the future you.
You from the
So,
future!
yes.
I've come back
We,
in the past to tell you your code is crap! Write it better!
yes, many coder have definitely read code from even a week ago, and it's just like, what happened? What was I thinking? What was I on? Why did I do this? And so keeping in mind that like someone else may be using the code that you're writing, even if it's just yourself, it will help a lot as you're going through your coding journey.
Hmm. Yeah, that's great advice, and I can't say that that's that. Yeah, I'd say that's right. The other question I have is, let's assume that there's somebody out there, maybe you from the past, maybe somebody else who might be looking up to you right now and thinking like, well, maybe I should be a software developer. What would you say to them, and where would you say they would start? They should start.
Hmm. I guess I would say it's such a hard question to kind of answer since code is just a vast ocean of things to learn. Um, but I would say to start if you've never coded before in two places. So in the first place, I would say the best way to do it is just sort of pick up a compiler, even if it's just online. Like REPL.it is a good place to go if you don't want to like go through the rigmarole of installing your own compiler. Uh,
REPL.int.
oh, .it. So like
.it.
REPL.it. Yeah.
REPL.it. Okay,
Yeah.
REPL.it, right?
Mm-hmm.
Okay, cool.
And so that's the name of it is a bit of a joke, which I'll say Google REPL for those of you curious. And the other thing is to, once you sort of plateaued the first time and you think you kind of got the feel of a language, is read Pragmatic Programmer. It's a book that is very, 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 very essential, I would say, for beginner coders because it sort of like brings you into what to expect from your code, what you should be looking for, what you should be striving for, sort of like as your first steps. Well, we'll say your next steps um,
So
down your
that's
coding journey.
REPL.it. Code, create, and learn together. Here we are. Start coding. Cool. Features and all skill levels. This is cool. Yeah, okay. I can see why this would be a good one.
Yeah, the
Yeah.
best thing about REPL is that I think they have so many different languages that they support. And also, if you're into like servers and you want to try your hand at doing something like Node.js, um, they also have things like that. So you wouldn't really have to figure out how to upkeep your own public server, and they'll host it for you for free.
Wow. Cool. So REPL.it, and then what was that other one that you were talking about? Oh, wait. You were talking about Passionate Programmer, right?
Oh, the Pragmatic
Oh,
Programmer.
yeah. There's another one called The Passionate Programmer. Is one that I like. Let's take a look at where that is. Looks like you can find it on Amazon pretty easily. There it is, The Pragmatic Programmer. Cool. By David Thomas. Not the same guy who makes Wendy's, right?
It would be so cool if it was.
All right. So, all right, cool. Those are great suggestions, and thank you for that. And since we are now at the end of the show, it's time for our awkward software developer exit. Are you ready for this?
Oh, that's the best thing.
Okay.
Never are.
I think we're done now, right?
Yeah,
So,
I think so.
all right.
I'm not quite sure how to maybe is
Right.
it now it's windows are everywhere.
Oh,
No.
there we go.
Okay.
I think I put up something. Oh wait, I did. There's music playing now. Okay, so
those are the
that's.
reactions. That's not correct.
Oh, right. Oh, okay.
No. Okay, so that's that. That's the chat. Okay. I think I found it. Okay.
steps I can. Steps too high. I'm just a man. If you see my face at your hour of death, don't shake. Don't shake in your boots, no, don't you fret. Cause I'm gonna take you down where the beats are pumping. Down to hell where the lava's jumping. In the mountain, lava's jumping. Down to hell where the lava's jumping.
Let yourself fall, cause you'll only get higher. Let yourself drop like a bee on fire. Living half dead, so you might as well drop. The f***ers can't find you, the beat don't stop. The beat don't stop. It'll never stop.
I walk this life. The only steps I can. Steps too high. I'm just a man. I walk this life. The only steps I can. Steps too high. I'm just a man. When you start saying a mountain is a mountain, a river is a river. Well, living Zen, a mountain is not a mountain, a river is not a river. After living Zen, a mountain is a mountain,